Bismillahirrahmanirrahim. Assalamualaikum and good day. In this video, I'm going to demonstrate how we are going to undifferenced data. Okay, let's say the data, we input the difference data in the coding, and then the output also in the difference scale. Okay, first I show you from the beginning where let's say we transform the data into line scale. Okay. So this is the original data, and then this is the line. And then from line, let's say we take difference one time at non-seasonal lag. Okay, this is d, small d means that at non-seasonal lag one time. And then let's say we difference also at seasonal lag. So difference at seasonal lag, this is monthly data, so we will lose 12 data, so start from 13. Okay, this is the first data that we have. Okay, so this is, sorry, should be line minus. Okay, so this is only the seasonal lag. And then if we difference at non-seasonal and seasonal, okay, this is the data. Okay, so different one time. Okay, so 14 minus 12 is 2. So if we different 2 times, means that at the non-seasonal and seasonal, so we will lost 13 data. Okay, so let's say the testing data is the last 12 data. Okay, this is what is the testing part. Okay, so we assume that this is the, okay, I just show you the double differencing when take non-seasonal and seasonal lag, how we going to transform back the data. Okay, I just give this as example. Okay, let's say this is the output of forecast in difference and transform data scale. Okay, so this is the output, for example, for forecast. So we assume that we don't have this data. Okay, so we reserve it in order to find the forecast error afterwards. So here is the difference and transform data, right? So we need to transform back the data, so then we can calculate the error in the original scale. Let's recall the equation of difference data. Okay, let's say we different one time at non-seasonal, so it will become yt minus 1. So when we difference again at seasonal lag, so yt prime minus yt minus 1 prime, so 12, right? So minus 12, and then minus yt minus 1 minus yt minus 30. So this is minus, so plus. So it should be in bracket, so I open up the bracket, so this should be one bracket for this one, and then this one is minus for this one, so I open up the bracket, it will become positive. Okay, when we look at this equation, okay, the double differencing is equal to yt minus 12 minus yt minus 1 plus yt minus 13. So we assume that this is the output in this in the difference and transform scale. Okay, note that this one is yt, this one is also yt, but this is at original scale and this one is at difference scale, so we need to put as yt equal. So then we want to transform it into original scale. So yt is equal to yt double prime plus yt minus 12, this one should be minus, and then plus yt minus 1 plus minus yt minus 13. Okay, so this is how we are going to undifference. We call it undifference the data. Okay, so let's test the in sample data first. Okay, so this is the original data in difference and also transform scale. Okay, so let's transform back this one into this one. Okay, so yt, okay, this is yt that we want to find in the original scale, equal to double prime data. So this is the double prime data plus yt minus 12. So this is 14 data minus 12 means that 2. Okay, so plus 2, and then minus, plus, okay, plus yt minus 1. So t now is 14. Okay, this is 14. Okay, look at this t. Okay, t minus 1, so means that 13. So 13 we take at the original data. Okay, because this is yt only, right? It means that at original scale. Okay, our original scale is yt, yt minus 1 is this one, and then also this one, right? This one is ln. Okay, and then minus yt minus 13. Okay, 14 minus 13, 1. Okay, so minus 1 equal. Okay, so when we check back the data, okay, this is the difference data, and then this is undifference. So it should be the same with this one, which only consists ln. Afterwards, we can take exponent. Okay, so again, follow this equation. Okay, yt double prime is this one, and then the rest is in ln column. Okay, so I demonstrate like this because you can check whether the answer is correct or not. Okay, otherwise if it's fitted, let's say, and then you cannot check whether you have undifferenced the data correctly or not. Okay, so this is for this one. Okay, double prime just now. Okay, then we compare with the ln data, so it's the same by using this equation. So next we're going to do the same thing for outsample data, which is we assume that it is focus. Okay, I just copy this equation below. Taking this one and then put down. Okay, this is the equation that we are going to follow. Okay, again, this is the outsample. Okay, this data at the difference scale, we assume that this is the focus from the output that in difference scale. So I assume here because afterwards you're going to check whether it's correct or not. Okay, so here just now the same equation, so of course it's the same with this one, right? But remember that this is the outsample data, that we don't want to use it because we assume that we don't have this data. Okay, so taking the same equation, okay, this data, okay, because this is output, so we have the data, right, from the output. This one is the last observed data. We assume that this is the last observed. It comes from here, but we take ln, right? So this is the last observed data that we have. Okay, so next data, okay, the second focus. Okay, it took the data from this one, right? Okay, this one shouldn't be used because it come from this one, our sample, right? So instead of taking this one, we take the previous forecast data, because we take we undifference the data one by one, right? Okay, so now this one is okay, right? The first one, okay, this one already we have this data, this one is from the forecast. So the next, okay, data forecast, okay, we just simply take the previous forecast data, not the previous observed data, because we don't have this. Okay, we assume that we don't have this, and follow for the rest. Okay, let's check it. Okay, so this one, okay, this one also can, because we already undifference it, can also until the last forecast. Okay, okay, done. Okay, so it should be like that if the output give in different scale, and then you need to transform back the data into original scale. So we take ln transform, so anti-ln is exponent, so taking this one exponent, so we obtain back the original scale data. Okay, remember this is just like simulation, because I want to demonstrate that how we are going to get back the original data. Of course, this one, let's say it is fitted, so it's not this same data as this one, because fitted come from the model, not come from the same or familiar with the observed data. This is just to demonstrate to you. So I already demonstrate to you the double differencing data. Okay, afterwards you can try on this one. Okay, this is my more simpler. Okay, this is just one difference data. Okay, one time is also one time difference, so you can try on. So this one, just use the first equation here. Okay, yt equal to yt prime plus yt minus 1, and then this one, okay, this one is only at seasonal lag, so t minus 12, sorry, not this one, okay, t minus 12. So you can try on. Okay, all the best. Assalamualaikum. Bye.